And right now we are going to dive into session 6, which is soil health economic benefits. And we have some great talent that is going to be talking to us about that today. And to introduce this session and the team that are going to be participating in it, I'm going to hand now the mic over to my esteemed colleague, Dr. Michelle Perez. As we mentioned yesterday, Michelle is AFT's National Water Initiative Director and the project lead of AFT's Economic and Environmental Case Studies team. So with that, Michelle, take it away.
Thank you, Chris. Let's see if I can figure out how to share the right screen. And I believe I'm on track. I'm going to make it the PowerPoint version of that. How does that look, everybody?
That looks great, Michelle. Looks great.
Thank you. Great. Well, it is our pleasure to be able to join you today. So many states from the western side of the country, so many land trust representatives. I'm going to let my colleagues introduce themselves, but I am Michelle Perez. I am the Water Initiative Director, reporting to you from my home office here in Silver Spring, Maryland. And we've compiled a great show for you today to dip your toe into the economics of soil health. And we have lots of sessions to get through, and I'll just proceed to share with you. If we can pull it off, we would love to accomplish 3 objectives with you. First, we want to teach you, the easement participants, about the costs and benefits of soil health and how to use a variety of resources we've assembled for you. 15 AFT-NRCS co-branded soil health case studies, slide decks to help you walk through those case studies in addition to handing them over. They're just 2 pages, but we've got some slide decks to help you walk through them. We've amassed economic findings from the literature, and you're going to be treated to a conversation with a soil health successful Idaho farmer named Pat Purdy. Second, we encourage you to collaborate with your local conservation professionals to share all these resources with them as you see fit, as they see fit, and ask them to serve as your technical service providers, because we know you're not soil health experts, but you're trying to play one on TV. And third, we hope to inspire you to find FRPP-related soil health successful farmers to feature in future local case studies to serve your needs even better. So the agenda is action-packed. We've got about 15 minutes per person. Hopefully we'll get through it all. I'm going to start off with these objectives, the background to give you some context, share findings from the AFT case studies, and explore options for your use with them. Then we're going to turn to Ben Wierzinski, and he's going to share with you what we call amassing economic evidence for soil health from the literature. Then Ben and Ellen are going to go into the Western case studies as they apply to you. And Ellen's going to have this wonderful interview with Pat Purdy coming up. And then we have 15 minutes for Q&A at the end. We'll also see you on Friday for a role-playing exercise. So how do we all get into the issue of quantifying soil health economic outcomes? Well, a lot of scientific evidence does exist already. That no-till, reduced-till, cover crops, nutrient management, conservation crop rotations, and other soil health practices do improve soil health. They do increase the water holding capacity. They reduce runoff, they lower climate emissions, and they sequester carbon. But not enough information about the economic benefits and costs have been quantified. And so the whole ag community, which is large, growers, landowners, ag retailers, bankers, corporations with sustainability goals, etc., they all want to know, what is this bottom line of investing in soil health? So back in 2018, we landed a big USDA conservation innovation grant, and we said, well, we hope to drive innovation and adoption of soil health practices by estimating these net economic and environmental benefits associated with folks who are soil health successful. They've already adopted these practices and developed 3 sets of economic tools: the retrospective soil health economic tool, or RSHEC, the PSHEC predictive, and the OSHEC online tools, which are a little grayed out right there because they're under development. And we're using that RSHEC tool to produce these case studies along with the USDA's nutrient tracking tool and Comet Farm tool to estimate the water quality, and the climate outcomes. We packaged this all into 2-page compelling case studies that we think are good enough for farmers to want to read and enjoy getting through. And we're empowering our fellow conservationists like you to produce your own case studies with your own local partners to feature those soil health successful producers in your own neck of the woods. Because our theory of change is the more local evidence there is, the faster we get more farmers to yes on more acres. And what is this soil health successful farmer we're talking about? Well, we have some strict criteria for reasons we hope you understand. And we're saying that, you know, soil health, as Bianca and others are going to be telling you about, it takes time to change the soil properties, the biology, the chemistry in the soil. So at least 4 years of successful adoption by a farmer is what we're looking for. And there's the long list of soil health practices on most of their acres, because we want them to be true blue believers, and they have economic positive stories to tell, and we help them quantify those stories further. And too many years is also a problem, so 15 or more years is a little too difficult for us to do this partial budget analysis before versus after economic analysis that we'll go into a little bit later. So after we package it all up, we go through NRCS review, and if we pass their review by their economists and their soil health scientists, they agree to put their logo on it because that increases readership and credibility, does it not? And we hope that if you were to partner with us, we'd get to put your logo on it or your local conservation provider's logo on it. So here we are, 15 AFT soil health economic environmental case studies. There were 3 featuring California almond growers and 1 in partnership with the Almond Board of California, 2 from Illinois and 2 from Ohio featuring corn soybeans, 4, excuse me, that needs to be, yes, that's 4. No, that's 5. 5 diverse row crop systems are featured from New York, 2 using a different data set, the New York Dairy Farm Business Survey data set. The one from Pennsylvania is our first and only FRPP-related one, and 2 from Oklahoma that we did in partnership with the Oklahoma Conservation Commission. So a huge thank you to all of these farmers, all of these partners who agreed to share their story and be featured in these case studies. The backside of the 2-pager looks like this, with this hopefully easy to read, easy to walk through, benefits on the left side, costs on the right side, and the net benefits there at the end. So what are we thinking? How are we thinking that you might use these case studies with your landowners and farmers? Well, first and foremost, before you begin, we're hoping you're going to reach out to your local conservation professionals so you can establish a working relationship with them, introduce them to your landowner and farmers to provide that technical and financial assistance they likely need to overcome their risk aversion to adopting these soil health practices. Share those economic case studies, fact sheets, and PowerPoints with them so to add to their conservation toolbox. They may be super excited to receive those from you, and encourage them to develop their own local case studies using the RSHEC toolkit I'll tell you about shortly. And then before you go out and talk to your farmers and landowners, print these AFT-NRCS case studies, the one that you think will resonate with your growers, your producers. Print the PowerPoint slides to use them as handouts. So we've got all these case study slides, a 6-slide approach, a 1-slide approach we're going to talk to you about. We've got these amassing economic evidence slides, and then any other resources that we've shown you or you pulled together. So just arm yourselves with all of these wonderful resources and know how to talk using them. So before we go any further, you were like, what is this economic method, this partial budget analysis that AFT has used? It's a very common technique to basically estimate the economic effect, both the benefits and the costs of all these different variables on the right-hand side that are affected by a change in the farming operation. And so it's a before you made the change, and what's the change? It's soil health practice implementation. And how did all of these things, what changed in regard because of that soil health practice implementation. And if nothing changed, we don't analyze it. We only analyze the changes. And how do we do this? So a 21-page questionnaire that our case study authors use to interview farmers. And then we have an 11-tab economic calculator that processes the information. And we use a variety of data sets in addition to farmer-specific information. And there's a link to learn even more about our methods. And how do we do our environmental analysis? We use the USDA's nutrient tracking tool to estimate water quality outcomes. We use their USDA's Comet Farm tool for greenhouse gas emission outcomes. And here's some summary findings. So of the 15 case studies, 10 of them featured row crop farmers, and that's corn, soybeans, wheat, alfalfa, and sorghum. And so all of you who are out there who have these farmers, you might find these next set of 4 slides very, very useful. So of these 10, 8 said, yep, I can attest that my yields increased because of these soil health practices. And 2 said, nah, I haven't seen any yield effect. All 10 of them reported net income improvements, and the range was between $4 and about $56 per acre. All 10 of them reported positive returns on investment, ranging from 7 to a whopping 343%. Inputs did change. Fertilizer costs, 5 of them said they were able to cut back and reduce costs. 3 saw no change, and 2 increased costs in relation to the soil health practices they adopted. In terms of machinery and fuel and labor and time, 9 of them were able to reduce their costs, while 1 reported no change. In terms of pesticides, 5 reported no change, while 5 did see some changes they were able to make. 3 farms increased their pesticide usage, and 2 were able to decrease them. The learning costs were very varied. It ranged between an increase in $17 to $160 per year, investing in reading, attending conferences, asking for advice about these soil health practices. For the environmental benefits and these water quality ones, all 10 farmers told wonderful stories about seeing less runoff, less soil leaving their fields. And when quantified by nutrient tracking tool, there was a lot of range of reduction. Nitrogen losses were cut in about half, phosphorus losses cut even more, sediment reduction losses down by 3/4. Climate improvements, the Comet Farm tool was able to estimate on average a very nice 188% reduction in the total greenhouse gas emissions coming from these farms. So in many cases, several went from being net emitters to net sequesterers of soil carbon. I'm going to quickly, I think I'm already at the time. I'm just glanced at the time here, and I'll just briefly get through the next set of slides to show you that if you wanted to talk about our FRPP case study, you can do so in 1 slide. And so this highlights this family that did put their farm under an FRPP easement. This shows you that right there on the first page, we talk about their commitment to passing the farm on to the next generation. And there's a great quote in there that says they don't know what the future holds for them and their farm and their 3 generations of farmers, but they know they've got to have healthy soil to get them there. So that's why they've invested in soil health as well. So you too can help us find that soil health successful Western farmer. And here's just a few of the criteria. They've got to have an FRPP easement, and they have to have between 4 and 15 years of successful soil health practice adoption on most of their acres with a positive economic story to tell. And please get in touch with Ben Rzazinski coming up. To access the case studies, it's as simple as AFT Soil Health Economic Case Studies. These keywords right here, you'll find them like that. And to get in to download the toolkit, AFT Soil Health Toolkit for you nerds out there who want to try your hand at becoming an author. We encourage you, please join us in this effort. And thank you. And I'm going to turn it over to my colleague now, Ben.
Thank you. So I will share my screen and start with our next presentation. But as I do that, I'll introduce myself again. I talked to everybody yesterday. And then, sorry, I got distracted by the share screen options, but I'm Ben Rzazinski. I'm an ag economist here. There we go. and I work a lot with Michelle and Ellen on soil health economics. So let's start this presentation on amassing the economic evidence for soil health. So as Michelle mentioned, AFT, we do produce our own kind of analysis, but I also wanted to look out for some analyses on soil health practice adoption from Western states on production systems that you all mentioned in the application are of interest to you. But before we start with that, I think it's important to start with what is economics, since this is an economics talk. So economics is the study of scarcity, the study of how people use resources and respond to incentives, or the study of decision making. As you can see from that definition, it's not the study of what's the bottom line. It's everything that goes into how somebody makes their decision. It's why people buy lottery tickets, even though we know it's not a good investment. And so it takes into account things like short-term versus long-term outcomes, riskiness, environmental benefits, personal and community values. All of these things are weighing through a farmer's head when they make the decision, in this case, of whether to adopt cover crops or not. And it also gives us some insight into why a farmer who might be experiencing a short-term negative financial result for one season might persist with the practice if there's some other values at play. So as we get into this presentation, I just wanted to start with setting the scene of soil health economics is complicated. There are multiple different practices, and they interact differently in different production systems. And I know Bianca talked earlier probably about how there's some core principles of soil health that go across all different types of production systems. But when we look specifically at practices and their interaction, it takes a lot of research from the economic side to kind of go into those. And so in the Midwest, where corn and soybeans dominate, and a lot of money has been put into research of soil health practices in that system, we are starting to get a clearer picture, but it's still a very nuanced discussion. But as we've now moved west, where there are a ton of production systems, it's a muddy water on how to talk about soil health economics. But hopefully after today, we'll start kind of painting a clearer picture for everybody. So first, I want to start with some work from our friends at the Soil Health Institute. They use a partial budget analysis similar to what Michelle just said, and that we use a lot of AFT, but they looked at 100 farms across the Midwest, corn, soybean, and they broke them down by states, and they didn't do individual case studies, but kind of compiled state level results. Two of the states they focused on have participants here today, Nebraska and South Dakota. So I pulled the results for those two states out. And as you can tell from the slide, both states paint a very similar picture, and that's mirrored across the other Midwestern states they looked at, of farmers are increasing their income with adopting these soil health systems, which include things like tillage reduction, cover crops, nutrient management changes. And the main drivers of that are increasing yield and decreasing costs. And that is what gets that net income gain that you can see in these last bullets. So if you want to look further into those, they call them fact sheets. We have a reference at the end. We can get you those documents, and the same goes for any of the things I talked about today. Next, I want to go to a modeled study out of California. So DeVincentis and her co-authors did a really interesting study using a present value model, and that's a fancy way of saying that they took yearly costs and benefits over a time frame, and then they brought them all back into one value for today, looking at cover crops in tomato and almond operations. And so they built out that yearly model using farm budgets, farmer interviews, research trials. And so in their baseline, they found in their benefit cost ratio, which is simply benefits divided by cost, that almonds had a positive ratio, meaning benefits outweighed costs, but tomatoes had a less than 1 ratio, meaning cost outweighed benefits. But that's not the end of the story, as they kind of went through and they said, really, we're living in a very dynamic time where things around soil health practices are changing rapidly. Specifically in California, they mentioned climate, hydrology, and policy changes. So they tested different scenarios, and they came up with 2 results where both crops had these greater than 1 benefit cost ratios. And the first was that when there's a lesser chance of harvest complications. So with cover crops, you're putting them in generally right after a harvest, and so that can cause chaos at the harvest time, which is always stressful for farmers, and especially for tomato growers where they're in these strict contracts most of the time. That can be a very large negative cost to growers. So they, in their model, they said, what happens if we give a little bit more flexibility around that harvest time? They saw that cover crops then had a greater than 1 benefit cost ratio, and it kind of spoke to how we need to start maybe rethinking those tomato contracts. And the second thing they went to was, what if we put a greater importance on cover crops decreasing summer irrigation? So we all know that cover crops increase water storage benefit. That's a huge thing for the dry, drought-prone areas of California. So if that becomes a larger issue than it already is now, which is a huge issue, cover crops will gain importance because they have those great benefits to water storage capacity. Next, I'm going to go through 4 university research trials, which are great replicated kind of top line, just really analyzing the results of these practices. So the first one from Washington State, Jurgen and co-authors look at in inland Washington, where winter wheat dominates, conventionally tilled winter wheat dominates, what would happen if we start looking at no-till or reduced-till alternatives? So in their research trial, they tested those alternatives and compared them to neighboring farms that were just doing the conventional tilled winter wheat. And they found that winter wheat with a fallow spring and summer was most profitable. But a no-till spring wheat was also profitable. And that was before they didn't add in any kind of erosion control benefit, like a monetized benefit for that. And they said that if they did add that in, they probably would have seen no-till spring wheat being a better option. And so I think that's really important when you're talking to farmers, is that they make sure that you mention that, a lot of these things benefits aren't going to show up in a traditional farm budget. And so you need to slightly think outside the box for the benefits that they might incur. The next is from Missouri, Belt, Knapp, and Nelson. They looked at evaluating long-term effects of different no-till and reduced-till rotations in Missouri. So Missouri, corn, soybean, wheat rotations are really dominant. So they looked at different variations of no-till and cover crop and reduced till within that. The recommendation was that reduced till corn followed by reduced till wheat, double crop, no-till soybean, and then a year of no-till soybean was the best option. So this is highly specific advice for Missouri. But I also think it speaks to the importance of how regional these practices are, and the need for that great regional research. So if you aren't finding the resources that you need for your area, it's really important to keep pressing and asking NRCS extension for these resources, because lots of them are quite specific and localized. Another Missouri one, Kai et al. Look at the testing of cover crops in Missouri with wheat, corn, and soybean rotations. And they find that they did a year-by-year analysis for 4 years, and they compared the revenue from the cover crop field, which was a mixed cover crop blend, to the traditional no cover crop field. And they found that in year 1, a large difference in revenue from the cover crop field compared to the traditional. And that was really driven by having the wrong type of application of cover crop seeds. So as they learned that the next year, they almost broke, comparatively even with the traditional field. And then in the third year, they had some weather issues, so they didn't get results. But by the fourth year, the cover crop field was making significantly more money per acre than the no cover crop field. And they really attribute that to spending time to find the right way of applying the cover crop, and then also those soil health properties building led to a yield increase compared to the controlled field. And this is a thing that we've noticed a lot through all this research, is that there is a time component, that it takes a little time to experiment and get what works for each farmer, but then it takes some time for soil health to build to see those potential yield increases down the line. So we like to say that soil health is not a short-term investment, it's a long-term investment, and we really need farmers to start thinking about it that way. And then the final one of these research trials I want to bring on is from New Mexico, and Archaria and colleagues about testing 7 different types of cover crops and winter wheat systems there. And they found that all cover crop systems had positive net returns, but none were as profitable as leaving the field fallow. Of those cover crop mixes, peas were the most profitable, but they did say some very interesting things in their conclusions about this, is that when they added in a factor for erosion control, saving $30 per acre, which they found in the literature, as well as an incentive, that then cover crops became the better option, the more profitable option. And they also noted that this was a short-term study. And as I just said, that we know that some of these things take time to implement. So that's an important thing when looking at these studies, is are they short-term or are they long-term? And even though this is a row crop training, I brought a couple grazing resources because I know that that's a big thing for a lot of people here. So in Oklahoma, SESTAC and co-authors did a randomized controlled trial to test the profitability of no-till and cover crops in winter cereal or pasture and summer cover crop systems. So no-till outperformed conventional tillage because of the reduced costs, but grazing cover crops still didn't create enough revenue to outweigh the cost of the cover crops. And I recently talked to one of the co-authors, and he said, you know, this was an interesting finding. They're really excited to do more research on this, and that there just isn't enough research done yet on these grazing systems to really have a great understanding of what's at play. And then the final from Wyoming, Dyer and co-authors use a net present value model, similar to what I just explained, to test the effects of grazing management and rotational management. And if forage yields occur instantly, the model showed positive results. But if they occurred later on in the model, then the net present value was negative. And it just shows the importance of, you know, in that short term, it can be very, very difficult for farmers to overcome that short term. And so that's where some incentives or something could be very beneficial. But speaking of incentives, I'm going to move over to surveys now in the last two things as I quickly try to wrap up. So there are 2 surveys I wanted to bring up: USDA, the ARMS survey, and the SARE cover crop survey. One thing I wanted to point to from both of them is that the first finding is that a large amount of farmers are not using incentives to grow cover crops. So if you don't have an incentive package that you can offer a farmer, that's okay. Farmers are still adopting. The second, coming from the SARE cover crop survey, who sample over 1,000 farmers every other year about the cover crop practices, as you can see, yields are increasing from the farmers in their sample. But another important thing I want to spend just another minute on as I wrap up is that a couple of years ago, they did a more in-depth economic look. And it's that same timing that I mentioned before, which is in year 1, they saw corn net income and soybean net incomes being negative. But by year 3, they had pretty much broken even. And by year 5, they had positive results. And it just shows that same important thing to stress of it takes some time for these practices to really work out. So that's where I want to leave you with that. We have all the references. So if you have any questions about these things, please talk to us or yeah, we'll get in contact and we'll try to help you out. And then I'm gonna switch it over. Ellen, if you wanna share your screen. Okay, yeah, so Ellen is sharing, but I'm gonna start off this presentation about our AFT Western case studies. And so as Michelle mentioned, we've got a series of AFT Western case studies. 3 are on California almond producers, and 1 is on Ellen's going to run through is an upcoming case study from Peekaboo Livestock Company, and that will prepare us all for her conversation with Pat Purdy coming up. So these California almond case studies, they are from almond producers across California. You can find them on our websites. We also have individual slides about these producers at the back of this presentation that we've shared with you. I'm not going to go into those today, but I'm going to go over some high-level points. So Ellen, next slide, please. So the 3 orchards that we've highlighted, Faith Home Orchards, Akuya Farms, and Rogers Farms. Faith Home Orchard, we're looking at their adoption of clover and mustard cover crops. And then for the other 2, looking at their adoption of conservation cover, nutrient management, composting, and mulching. Ellen, if you could go to the next slide, and then just a quick economic summary. So all 3 showed really large positive net income changes due to the adoption of these practices, ranging from close to $500 to $1,000. And they all kind of had very similar stories where these large increases in net income were brought about by positive change in yield, followed by a reduction in total on inputs, as well as an increase in learning costs. And that's something that Michelle mentioned earlier, is that we want to make sure we highlight that these practices, they take time to learn about, and it takes time, farmers willing to spend their own time to learn about them. But the story here is that even with that increased learning costs, there were enough increases in yields and decreases in inputs to have that large net income change and a large return on investment. Ellen, next slide. But that's not the only benefit. We also looked at the environmental benefits, and for greenhouse gas emissions using Comet Planner and Comet Farm, you see large reductions for all 3. And then for nitrogen, only Akuya Farms that we looked at had a very large reduction, but no increases, which is also very important. And so, as I said, the individual slides for this are going to be in the back, and they're going to mirror the same format that Ellen's going to run through right now with Peekaboo. So I will hand it over to Ellen and let her go into this really exciting case study we have coming up.
Great, thanks, Ben. Good afternoon, y'all. My name is Ellen Yateman, as Ben said, and I'm actually based in Driggs, Idaho. I am an agricultural economist as well. I actually received my master's in Ag Econ from the University of Wyoming. And I've been with AFT now for 2.5 years, where I've been conducting research on the on-farm economic trade-offs of adopting soil health practices, primarily through production of our soil health economic case studies. And today I'm so excited to present the preliminary results from our first Intermountain West soil health case study by AFT, featuring Peekaboo Livestock Co., which is located near Peekaboo, Idaho, as one could guess. And the following 6 slides, as been mentioned, are our standard approach for presenting case study results, which we encourage all of y'all to use anytime to walk an audience through our case study findings. So over the past few months, I've met with Nicholas Purdy and then more recently his uncle Pat Purdy, both pictured here, over virtual phone calls to learn about their family's ranch, which has been in the family for over 135 years. Pictured next to Nicholas and Pat is the patriarch of the ranch, Nick Purdy, who's Nicholas's grandpa and Pat's dad. And together they manage around 4,800 acres, but for this economic analysis, we focused on 1,800 acres of fields and purely a 2-year barley, 4-year alfalfa rotation on average. And outside of the study area, they also grow mustard. That's a more recent endeavor, and every 8 or 9 years, they'll grow potatoes as well in their rotation. And in 2014, Pat began experimenting with no-till and compost, and has since then implemented no-till across all acres and applies 100% dairy manure compost to their alfalfa, replacing synthetic fertilizer. And in 2015-16, they began experimenting with cover crops, which they continue to do, but they most consistently cover crop a dry forage mix after barley harvest into volunteer barley and have their cattle graze it. So for these soil health practices listed here, our case study estimates that they've increased their overall net return by $65 per acre per year, which across 1,800 acres is almost $120,000 per year. And this translates into a 136% return on investment, meaning that for every dollar invested in soil health, their net returns have increased by 36 cents. And for these slides, we like to include a motivation slide in these presentations and listed resource concerns. Here are some of the motivations that Nicholas and Pat have mentioned to me. Uncle Pat actually first introduced the idea of implementing soil health practices after learning about no-till at the Pacific Northwest Direct Seed Association conference and through a local farming mentor. Pat also credits his father and grandfather for instilling a sense of duty as stewards of the land, and as Pat told me, and he'll hopefully tell us again today, once he began to see the soil as a living biological system, everything changed. And from a financial perspective, they also saw the potential cash savings if they could reduce input costs with healthier soil. And in addition to being soil stewards, they recognize that soil practices would help them address some resource concerns such as soil erosion, insect pressure, and soil compaction. So now I present the detailed results of our partial budget analysis of these adopted soil health practices. And this table shows the estimated increases in net income, hence the green color. And starting with increases in income, we estimate that the Purdy's grazing of cover crops has added approximately 1/3 of a ton per acre of forage on top of their volunteer barley that they usually graze, which we value at $74 per acre. And cover crops are usually planted on about half of their barley acres on average, hence the acreage adjustment. Also, Nicholas was great and was able to pull his crop rate records from the past almost 10 years. And we were able to look at yield changes on these fields. And we found a 9% and 25% increase in barley and alfalfa yield, respectively. But we attribute only about 50% of that yield improvement to the analyzed soil health practices to discount other variables. Which results in an estimated 5 bushels of barley per acre yield improvement and a ½ ton of alfalfa per acre yield improvement, which in total we value at $71 per acre. And so this results in a total increase in income for the study area of almost $150,000 per year. The next part of this table is the decreases in cost. And machinery cost savings are captured due to adopting no-till, and we value that at $49 per acre. And we account for the fact that this benefit is only incurred in the planting year of alfalfa with an acreage adjustment. And the Purdy's are no longer applying insecticides to alfalfa, valued at $8 per acre savings. So the total decreased cost for the study area is almost $54,000 per year. In summary, annual total increased net income for both increased income and decreased cost is about $203,000 for the study area, or $113 per acre per year. And this table shows the Purdy's estimated decreases in net income, hence the red color. So starting with decreases in income, there were none identified. But there are increases in costs as expected, including the cover crop seed and planting costs are valued at $69 per acre for a dry forage mix, which includes a lot of different things: peas, lentils, triticale, spring oats, spring forage barley, and an inoculant. The additional cost of adopting new soil sampling methods like the Haney test, chemical extraction tests, and aggregate stability tests, we value at about $3,600 per year. And then the additional cost of compost compared to the synthetic fertilizer that they were applying to alfalfa, we value at a $42 per acre increase in costs. And the added machinery cost of switching from dry to liquid split application on barley and custom higher spreading and manure on alfalfa acres, we value at $5 per acre increase in cost. And finally, we include a cost to these learning activities by estimating about 50 hours per year that everyone on the team spends on figuring out these new practices. So this results in a total increase in costs for the study area of $86,000 per year, or $48 per acre per year. So taking the results from the previous two slides, we summarize here the total annual per acre increase in net income of $113 per acre on the left, and total annual per acre decrease in net income of $48 per acre on the right. And by subtracting the decrease in net income from the increase in net income, we arrive at an annual change, per acre change of $65 per acre per year. And this is a 136% increase in return on investment, as I mentioned earlier. And the final slide of what we call our 6-slide presentation, we like to, of course, mention the barriers that to adoption and hurdles that they've faced. So we recognize that we break it out into 3 categories: financial barriers, technical barriers, and personal barriers. And Pat will talk a little bit more about this in our conversation. And sometimes you don't have an opportunity to go through that 6-slide approach with an audience. So here's the 1-slide approach to just call out the highlights of the soil health successful farmers' economic story. So lots more information put into 1 slide. And with that, now I'd like to introduce Pat Purdy, who's joined us today. And we're so grateful he's able to make time, even though they're finally getting out to plant.
Yes, yes. Good afternoon, Ellen. Good afternoon, everybody. I'm going to assume that there's an enthusiastic, excited group of people out there listening in today. I'll enjoy myself talking to my computer here. So
let me see if I can figure out stop sharing. Okay, there we go. Great. Well, Pat, I saw a hand come up, Ellen, up there for a minute. Is there any, can you hear me okay? Oh, yeah. Is there a hand? Someone have a question?
That was the way that we were waving at you.
Oh.
I know that we were here.
Hello. Hello.
Virtual waves.
Okay. All right. Gotcha. Virtual wave. Okay.
Well, Pat, why don't you just tell everyone a little bit about yourself, your role on the ranch, and how long you've been working on the ranch?
Well, as you saw the little bit of the bio there with my father, Nick Purdy. The property was that we currently operate was homesteaded back in 1883 by my maternal great grandparents, and then my grandfather, the late Bud Purdy, worked on the farm as a young child, and then was asked to take it over by his grandparents when he graduated from college in the middle of the Great Depression. And so he did that, and we've been here ever since. And so he raised his family here, my father and my aunt and uncles, and us us boys were all raised here. I've got 2 brothers, and one of my brother's sons, Nicholas, is the nephew that you saw in the introduction. And so right now we have 3 generations working side by side. My dad just turned 83 on Monday, and I turned 60 recently. And so we're very happy to have some youthful energy in Nicholas here. So, we farm alongside a beautiful stream, a world-class trout stream called Silver Creek. We're just down south of the Sun Valley Ski Resort area, about 35 minutes, and we're about 4,800 foot elevation, and we are pretty much 100% irrigated. And as Ellen mentioned, we raise about 2,500 acres of the number. Don't quote me on my numbers, but about 2,500 acres of dairy quality hay, 800 to 1,000 acres of pasture ground that we cut for hay and graze both, and then some mustard seed and about 15 to 1800 acres annually of malt barley for Anheuser-Busch and Coors, and 700 head cow-calf operation. And yeah, so I think that's, and we run a private fly fishing club on our property as well. So
great. Well, that was a great introduction to the ranch. And what's really great, and it was kind of a coincidence for this event, Pat, y'all have a conservation easement on your ranch. Yes. And that is, I believe, owned by the Nature Conservancy. Why don't you talk a little bit about when that happened and came about?
So I apologize, I should have the date specific in my head, but I believe it was 1995. That was, okay. I think, one of the first or the first one in this county or in this part of Idaho that was arranged with the Nature Conservancy. That was back, unfortunately, before they started paying money for easements. So that was just a donation, essentially, that my father and grandfather made. I believe it's on approximately 3,500 acres of our property. There's some wasteland, some ground that wasn't really suited for the easement, but it encompasses the vast majority of our property. And so that, non-development conservation easement. So we work very closely with the Nature Conservancy and have had and maintained a great relationship with them. They've been a great partner to work with. They have been in the business of working with us and asking us how they can help versus telling us what to do. So I've always appreciated their approach to our relationship. So
great. Well, I'm sure we can talk a little bit more about that as throughout the questions I have for you. But let's hop into talking specifically about the soil practices I just introduced. So, I just briefly showed some of those barriers and hurdles to adopting those those soil practices. So what are go into more detail about those barriers and hurdles y'all faced when you began no-till cover crops and changing nutrient management?
I've heard this said before, and I agree with it. The biggest barrier, particularly for, an older individual like myself, is what we already know. Right. That is one of the biggest barriers, is that we think we already know what we need to know. And you have to really get past the fact that the way your grandfather most likely and your father most likely, maybe your uncles, the way they have farmed is really not very conducive to soil health. The way that we've been farming for the last, for thousands of years is not conducive to soil health. And just kind of getting that in your head is really a difficult thing to do. And getting over the kind of the embarrassment maybe, or the pressure of being judged by the people around you, the community around you. I'm not a sit down in the coffee shop kind of a guy, but I know a lot of farmers are. And you've got to get over the ribbing and the chiding you're going to get from your neighbors, or maybe the outright criticism you're going to get from your neighbors about the things you're doing. Because, let's face it, even I enjoy appreciate the beauty of a freshly tilled field, planted in nice, perfectly straight rows. You drive past it on the highway. It's just like, gosh, that's just gorgeous, right? Well, it is pretty, but it's also the sign of a very destructive behavior. And so you've got to get used to the fact that your fields are going to look a little scraggly, because when we go out and plant a field into barley, we're planting right into last year's stubble, whatever stubble that might be. It might be mustard stubble, it might be barley, it might be alfalfa. It doesn't look very pretty. It looks like a field that's not finished. And it looks that way for, the next month, until that barley is up and about into the maybe stem elongation or booting stage. And when that finally covers up that residue that's underneath it, it's just not as pretty looking. And there's just a lot of peer pressure. And I think you've just got to acknowledge the fact with a lot of the farmers you're going to work with, that peer pressure and that pride that is inherent in that tilling the soil is a difficult hurdle to overcome mentally, particularly for older, more established farmers.
Well, that feeds in perfectly to my next question of, what do you do or what have you done to overcome these barriers, and, what contacts, resources were useful to you?
Yeah, well, I don't go to the coffee shop, so that I drink my coffee with anyway, you've got to be confident in what you're doing. And to do that, I think you've really, the number one thing that I would encourage people to do is you've got to find a mentor or a group of mentors that have gone through this before, that are further down this path than you are. This is a journey. This is not a destination. This is a continuous journey, and you're going to find people who are in various stages of this journey, and you basically just ask them if they'll help you, and typically I've found that almost all of them will. People who are doing this are doing it for a lot of good reasons, and they've all been very willing to help out. And I had some very important mentors, and I still rely on some of those guys today. I found a lot of great resources on the internet. If you just Google regenerative agriculture, you will find all kinds of information now on the internet. There's some wonderful resources from John Kempf and his regenerative agriculture podcast, Gabe Brown and all the work that he's done. There's a very simple kind of introductory book by John Sticka called the Soil Owner's Manual. 100 pages, very easy read. Some really great resources out there, both podcasts and videos and books that people can read. So there's no shortage of that anymore. So I would, but having a personal mentor that you can either come and look at your property or talk to, either on the phone or online, it would be incredibly valuable, because you're going to make some mistakes, and you're going to get your nose bloodied, and you need to have somebody to kind of help pick you up, dust you off, and set you back on the right path.
Yeah, I remember you mentioning to me prior, and I mentioned to this a little bit in the presentation, you first discovered, or maybe not first, but one of your, you learned about no-till by attending the Pacific Northwest Direct Seed Association conference. So tell us a little bit more about, attending that, and then the next steps in finding your mentor, John, and
well, that's an organization based out of the Pacific Northwest, primarily Oregon and Washington and northern Idaho, mostly dryland areas. I'm one of the few irrigated people in that group, but I think I can learn an awful lot from dryland folks. I mean, if those guys are very efficient at using moisture, very efficient at their planting methods, and they tend to run very large acreages. And so they've got some really tried and true practices. So an organization like that was invaluable, finding, just being able to ask the why questions. Why did you do this? Why did you do this? How did you do this? And I did find a more local person here in southern Idaho named John McNabb, who has since passed away. And he was a tremendous help to me. And he literally did have to essentially pick me up and dust me off a couple of times when we made some mistakes, because you are going to make some mistakes. And so that's important to have that personal touch if you can find it.
Yeah, speaking of making mistakes, we've also talked a little bit about experimenting on a small scale first, and how important that is. And
yeah, you want to only put as many chips on the table as you can afford to lose. Traditional tillage practices, traditional farming practices, we have a very well established set of tools. We know exactly what equipment, we know how to set the equipment up, we know how to do that stuff very well, right? Farmers in this country are really good at doing conventional farming. But making the switch over to no-till, you've got completely different equipment, you've got a completely different set of tools that you've got to adopt, and most importantly, a completely different mindset. That is the thing that is most challenging, is you've got to completely change your mindset. And so you've got to make sure that you start small. You've got to make sure that you start in the size of a field that you can afford to have a little bit of a mini disaster if that is what happens. And so we introduced ourselves fairly slowly. Started out with 30 or 40 acres, then moved to 200 or 300 acres the next year, and then we just expanded through the operation. And as our equipment, bought bigger equipment, and were able to run more acreage. And so it took us probably 4 years to fully implement the no-till practices.
When y'all were experimenting with no-till, when did y'all go out and get the no-till air seeder?
Well, we started out by borrowing a box drill the first year. That was successful. So then we bought a 15-foot box drill, and we used that for several years. And as our acreage that we're converting to no-till just got too large, that we just couldn't keep up any longer. So we sold almost all of our conventional tillage equipment at once. We sold 2 conventional drills, sold our no-till box drill, sold some of our tillage equipment, and basically raised enough capital to be able to go out and purchase a really good used no-till air seeder. And I believe that was 2018, if I remember correctly.
Awesome. Great. And so now let's talk about the benefits you've observed since implementing these practices and overcoming those barriers.
Well, you know, I certainly believe I love to go out and stick a shovel in the ground. That's one of my favorite things to do is just to go through the fields, walk out, you know, take different spadefuls, turn them over. You saw a picture of one of those. You know, the worm population. You know, again, I don't have specific analytics, but I believe we're seeing a significant increase in our worm population, the tilth of our soil, the water infiltration capacity of our soil. We just don't see standing water on our soils. I can irrigate as much as I want, and I don't see runoff. My pivots don't get stuck anymore. For those of you in irrigated system, that's an incredible cost savings to not be out unsticking pivots all the time. We don't have the wind erosion. I mean, we have spent part of our stream restoration efforts here. We've spent hundreds of thousands of dollars, literally probably over $1 million over the course of the last 15 years on stream restoration. It's almost exclusively centered around removing silt out of the stream. And that silt is accumulated there primarily from wind and water erosion from us and many other farmers in this area. And it's just heartbreaking to see your topsoil investment blowing away. And I don't know how people do it, honestly. I can't tolerate it. And so that was probably one of the most important factors that really made me decide we're going to do this, and we're going to stop, you know, with the farm-wide tillage that we used to do, and leaving all of that ground bare all winter long. So if in your area that's a common practice, I would encourage you to really work with your farmers to change that, because leaving farm ground bare throughout the entire winter is really just a kiss of death for soil health and maintaining your topsoil integrity.
Yeah, and I know folks, I don't know about other states out west as well as I know Idaho and Wyoming, but it is windy. Yeah. Ellen mentioned this a little bit. I'm sorry, I don't want to take you off track, Ellen, but probably one of the most powerful conversations you could have with a farmer is just and you're gonna have to know them. You can't just ask these questions right off the bat, but you know, how do they view their soil? Do they view it as a living, biological, incredibly diverse system that they are essentially a steward of, or is that you know how they view their soil, living, diverse, biological system, or is it essentially an inert blend of aggregates and chemical compounds that provide a physical mechanism for holding up the plant and a pathway for them to get fertilizer and water to the plant? I mean, so those are two distinctly different views of soil. And unfortunately, I believe that a lot of people view it the second way, although I think if you talk through that with most people would say they view it as the first. So if you really do view your soil as a living biological system, if you really do accept that, it really does challenge you ethically, morally, to change your behavior, because everything that you do to that soil has some unintended consequences. Even the no-till that I do to it. I mean, I still disturb the soil somewhat when I go out and till, but to go out and do aggressive multiple tillage passes, to do the level of pesticide and synthetic chemical application that we do, it really challenges you when you really do believe your soil is a living system. And so, you know, we have discontinued the use of fungicides across the property. That includes fungicidal seed treatments and broadcast fungicides. We also discontinued the use of insecticides. I did that both really because both of those two things are targeted at killing something. That they're killing something living. I guess living fungal, either fungus or insects. I'm targeting and intentionally killing those. We still do have herbicides in our rotation. I would love to get rid of those, but I haven't figured out how to do that yet. So I'm not far enough down my path yet to tell you I don't use any herbicides yet. And to follow up on that, the removal of insecticide completely, what do you attribute that to? And are the plants just better, higher quality to deal with that pressure?
And there's, you can't just do that overnight. I mean, the reason that we're having to use so many insecticides in particular, and even fungicides, is because we have a problem. Mother Nature is telling us something is wrong. We've got a problem with our rotation. We've got a problem with something else that we're doing in our system. And we learned 2 years ago that one of the reasons we were having so much insect pressure is because we were using a pretty high portion of nitrate nitrogen. And we've learned since that time that nitrate nitrogen is a bug magnet. And it is the cheapest form of nitrogen, but it's also the least efficient, and it's a form that you really should stay away from. So we've converted completely away from the use of nitrate nitrogen over to urea when we do apply nitrogen. Nitrate signals, nitrate when it's being metabolized by a plant signals insects to come and attack them. And so I think once you start really understanding the why do I have bugs in my alfalfa? Why do I have bugs in my barley? Why? You start asking yourself why. You get to the root of it. It's like, well, this is because something I am doing wrong. I have done something wrong, and that's why I'm getting some insects. Now, why do I have grasshoppers? That one's a tough one because they sometimes you get grasshoppers. So.
Yeah. Great. Well, we kind of already answered the next question, so I'm going to skip down to our second to last question, which is, does having land in a conservation easement influence how you think about soil health on your farm?
Well, we didn't adopt these practices because we have a conservation easement, but we have a conservation easement because we have a beautiful piece of property in a very sensitive area. And we also adopted soil health practices because we have a beautiful piece of property in this very sensitive environmental area. So the reasonings are the same, but it doesn't necessarily just drive our decision making, but it has definitely helped the Nature Conservancy, and particularly the people that have been involved with the TNC in this area have been very forward thinking. They have provided us with funding. They provided us with assistance, with technical assistance, with we've got Brad Johnson we're working with here in Idaho right now. Very innovative thinker, working with growers across southern Idaho with the Nature Conservancy. So it's been a big help, but it hasn't been the driving factor, but it has absolutely been a big help.
Yeah, I didn't mention this earlier, so it seems like a good time to mention it now. Is your work just last year, y'all started a fertilizer trial where y'all tested reducing the amount of fertilizer you're applying on barley, right? You want to talk a little bit about that? It
was really centered around adopting what's called plant sap analysis. So we've always used soil testing, and we've used some petiole testing, but we got introduced to plant sap analysis through, honestly, through John Kemp's Regenerative Agriculture podcast. And we started pulling sap samples last year. And when you actually start paying attention to them, you realize, wow, I've been putting on way too much nitrogen. That's not what I need. I need more molybdenum. I need more manganese. I need more cobalt. I need more boron. So we have dramatically changed our fertilizer program this season based on what we learned last year through our sap analysis results to really put a lot more emphasis on micronutrients and even some biological compounds. And so we'll then start pulling sap analysis here when our barley emerges, and that will help guide our decision making. We'll no longer be guessing about what fertilizer application we need. We will be using the plant sap analysis, which is kind of the lifeblood, the circulatory system of the plant is where that sap is drawn from. Tells you, kind of like a blood test for a human, tells you what's going on at that moment in time in the plant circulatory system.
Yeah, it's really exciting. All right, final question. You've touched on this a little bit already. How do you like to be approached by conservation easement professionals about soil health?
Well, I love to be asked, how can we help? I mean, I love to, because we're already partway down the path. And again, I mentioned his name, Brad Johnson, who works for TNC here in Idaho, and he does exactly that. He called me up, about a month ago. He says, hey, what kind of things you're thinking about doing this year? I'd like to, how can we help? And, that's exciting. I love that kind of collaboration, because he brings almost a statewide view. So I can say, hey, what are other people doing? Or what's something really cool that you've seen somebody else trying that we're not doing? And so you all have that opportunity to help to bring a much larger point of view, regional perspective maybe that your farmer would appreciate.
Perfect. Well, that's all my questions, Pat, and thank you so much for taking the time to meet with us today. I know it's getting busy on the ranch. we have 10 minutes or so left for questions from the audience, if you're willing to.
Yeah, absolutely. Happy to take any questions. I'll make up whatever answers I need to.
And I think I can pull up slides if anybody wants. But yeah, Cynthia, you have your hand up. Go ahead.
So thanks, Pat. That was really fun to hear from you. And I was just wondering if you were to join a coffee clatch at your local coffee shop, what would you tell other farmers about your experience with this practice?
Well, I would tell them again that it's been in general a very positive experience, that we're very happy that we've done it, that we've seen big reductions in equipment costs, we've seen improvements in our soil health. And in general, we've seen an upward trend in our yields. Not every year, but in general, we've seen an upward trend in our yields. And just communicate that excitement. And I've done that with several. I mean, I'm mentoring a couple younger growers right now who call me from time to time to ask me some questions, and I love it when that happens, because that I know that we're having an effect. So I do see some questions here in the chat that I probably should look at, if you guys don't mind. So, Addie asked, what type of notable mistakes have we made? Well, we applied our in-row, we've tried to convert completely over to liquid fertilizer, put as much of that as we can down in the soil to minimize losses to volatilization. Put my fertilizer too close to my seed one year and had, like every other seed row, I damaged a little bit. This last season, we had a little bit of a mistake. We tried, again, to move away from synthetic fertilizer in our in-row planting, and we planted chicken manure pellets based on advice that I had gotten, recommendations that I'd gotten from several people, that this was going to be a wonderful thing. And what it ended up doing was creating a kind of ammonium intensive zone around the roots, and we happened to have some very cold, wet conditions last year, and so I ended up with some rhizoctonium infection on about a third of my barley last year because of kind of the combination of the chicken pellets and the cold, wet temperatures. So sometimes you don't want to just jump right off the cliff and do everything, all your acres one way. So we probably made a mistake in that respect. What do you think helped you discontinue your pesticide use? So again, we've eliminated the fungicides, the fungicidal seed treats, and fungicidal broadcast and pesticides. I think crop rotation is very important. If you're just in a straight line weed over weed over weed, or barley over barley over barley rotation, you don't probably want to get rid of your chemistry, because you are not, you don't have a diverse enough rotation. So we're trying to diversify our rotation enough. We're trying to, I guess, do as little damage as we can do with the fertilizer that we do use, that we're not damaging our soil biology. And some of it is you just at some point you do have to just take that step. And I felt like I was confident enough that we could get away with that, and I think that's been pretty successful. The insecticides can be a little dicey on the alfalfa. We still do get some alfalfa weevil or some thrips in our alfalfa, and honestly, I just look the other way. Some cases you just have to say, oh, I'm just going to accept that damage, and I'm going to maybe cut a little earlier for that cut of alfalfa. I'm going to get the bugs out of there by cutting the crop a little sooner than I might otherwise. So sometimes you do have to be willing to, to take it on the chin and just let Mother Nature play it out, but I just don't want to go out and kill all of my beneficials by applying an insecticide.
Pat, I have a follow-up question to that.
Sure.
Have you been able to cut fungicides applications on whenever you plant potatoes?
Well, so no, we rent out the potato ground. We do not do the potato planting ourselves, but I have given him some, some rules about what he can and can't do. I still do let him use fungicides. I'd like him to stop that. We've talked about him stopping that, and he's agreed to maybe try some experiments around that. But he definitely cannot do soil fumigants. If he's going to be on my ground, he can't do any soil fumigants, which he's fine with that. It's not been an issue. But of course, he does very extensive tillage, so I still do have to come in and fix my fields after he comes across them. So, yeah, the potato thing is a little bit counterintuitive to what we're trying to do. So we do try and get in behind him and plant a cover crop if we can. Get in and plant like a forage winter wheat or something like a winter tolerant crop right behind his potato harvest, just to keep that ground from laying bare all winter long.
Great.
All right.
And it looks like there's a question from Angels. You've done soil tests, including and plant sap analysis. Was there another type of soil test?
Yeah. So sap analysis is, we're still doing soil testing, probably on a little bit more limited basis, and then sap analysis. So we will, as soon as that barley comes out of the ground far enough for us to be able to pull a sap analysis sample, we will go ahead and do that, and that will help guide our next fertilizer application. So yeah, that sap analysis really is the key to understanding what the plant is really doing. So hi, Carrie. I know Carrie. She's asking if we've changed any of our grazing practices. Yes, but not anywhere near the degree that I would like to. So farmers are old school and stubborn, but cowboys are a whole nother level beyond that. So we do have a gentleman that's worked for us for many, many years and runs our cattle for us, and so we're slowly kind of twisting his arm a little bit about modifying grazing practices. But yeah, we have done some more cellular grazing, more intensive grazing. We actually did just sign up with Agoro on our grazing ground, or both our dry land. We have about 10,000 acres of leased dry land grazing desert ground that we operate on top of our irrigated ground, and so we are obligated with this contract with Agoro to adopt some new practices, and grazing practices are going to be one of the big ones, improving our grazing management practices, smaller paddocks, more frequent moving of the cattle, putting some more species diversity into the rangeland. So we're going to be spending some money this year and the next year doing all of those things. Plant soil testing lab, we use for sap analysis, we use New West. There's a lab in the Netherlands that's pretty common, and we decided to use, and then Apical Labs here in the Pacific Northwest does sap analysis, but we're using New West. That's not right. New Age Labs. Sorry, New Age Labs.
This has been fabulous. There's a handful of other detailed questions, well, maybe one or two, about the difference between a sap analysis and nutrient management. Could you tackle Nicole Warren's question?
Yeah. Sorry, I didn't see that one. I've never heard of sap analysis test. Can you explain how that nutrient analysis has helped you with nutrient management since changing from a plant tissue analysis to a plant sap analysis? Yes. Have you been able to reduce fertilizer amounts? We actually reduced so I'll go backwards. We actually reduced our nitrogen applications last year, in some cases by over 50% of our typical applications. And that was really a direct result of this plant sap analysis. So it's a process of going out and picking plant tissue, old leaf, so that the oldest viable leaf and the newest fully formed leaf. And you pull both of those, put them into separate bags, you get a large enough sample. You label those, put them in a little cooler pack, send them back to the lab, and they physically extract the sap out of I apologize to the scientist, I'm going to butcher this, but it's the phloem and the xylem in the plant. They extract that sap out of the plant, and they analyze that for the nutrient content. Then they give you a report that shows you what the old leaf and the new leaf content are. So that gives you some interesting data based on what, and then you have to understand, are the nutrients mobile nutrients like nitrogen, or immobile nutrients like most of the micronutrients fairly immobile in the plant. And so depending on whether they're a mobile nutrient or an immobile nutrient, you then look at the relationship of old leaf and new leaf, and that tells you, am I deficient or am I in excess? And particularly around nitrogen, it gives you some really fascinating information about your nitrogen use efficiency, and tells you what your efficiency use is in old leaf and new leaf, and what your nitrate concentration is, and what your ammonium concentrations are, both of which are unusable forms of nitrogen, telling you that you've got your plant's metabolites, or your plant's system might be locked up and unable to convert those to the amino acid form of nitrogen that can actually be used. So what we learned was that we needed to be applying a lot more micronutrients in the season to help the plant metabolize that nitrogen that we were putting on it. we were over applying nitrogen and not giving it enough of the micronutrients that it needed to metabolize all of that nitrogen that we're putting on.
Super, Pat. Thank you so much, everybody. I see Chris is going to carry us out here.
All right.
And I'll just say thank you for being a soil health successful farmer and sharing your time and your stories with us.